here with Commander Chris Hadfield, a Canadian astronaut, now retired, and Dr. Michio Kaku, theoretical physicist, also a very famous space in the world of astrophysicists. So we're going to talk about your guys' new documentary, MiniVerse, in which Chris basically drives around the continental U.S. and kind of shows a microcosm of what the solar system is, what it looks like. On the way, he picks up many of his esteemed friends, such as Michio right here. Can you tell me what the genesis of MiniVerse was? What kind of spurred a thinking of how do we tell the story of the solar system just on a road trip, so to speak?
Well, the solar system is so huge. The numbers are kind of staggering, 3 or 4 billion miles from here to Pluto.
Right.
And a billion means nothing to most people. The number is so big, it's almost just unimaginable. But most people have some sort of sense of some part of the country,
Right.
part of the U.S. And a lot of people have taken a road trip. So if you can make the solar system, like from the tip of Long Island to the tip of the Santa Monica Pier, then suddenly it has a frame of reference that means something. And so if you leave the tip of Long Island, how long does it take to get to Mercury? Or how long does it take to get to Earth or Mars? And what's amazing out of that is if you're driving all the way from the tip of Long Island to Santa Monica Pier, where Pluto is, you get to Mars when you hit New York City. Mars is that close. And what Michi and I did was drive from that part of Long Island, and we drove by Mercury and Venus and Earth, and then we stood by the Brooklyn Bridge and looked at Mars with the whole rest of the solar system still waiting for us out to the west. It's just kind of a way to put it into an encapsulated idea that makes sense to you intuitively.
Well, I'm a professor, and I deal with undergraduate students at the college, and most of the time they spend their time looking down at the floor. They never look up to find out what's out there. But then when you tell them what's out there, Mercury, Venus, Earth, Mars, it's so abstract, they can't get a handle on it. That's why this series was appealing to me, because it makes a solar system manageable. All of a sudden you can grasp the entire solar system in its entirety in terms that you understand, like a road trip. And so I think it means that the average person out there, buried with their textbook, reading the newspaper, wondering what am I going to eat for supper tomorrow, they can have an immediate feel for the immensity, the glory, the magnificence of the solar system.
Mm-hmm. How did you decide to pick up Michio on the way? Was it just kind of like, my friend's available, let's
if you were driving a Tesla across the country, who would you want to pick up and have ride shotgun for a while? And I was lucky enough to work with 3 very different but very brilliant folks who all had different backgrounds but different understandings of the solar system. So it was really educational for me. And talking to Michio about anything is fun. But of course, having the planets roll by and the difference between the solid frozen water, the ice that's on the poles of Mercury, right through to the blistering, unbelievable heat and pressure down on the surface of Venus. We weren't short of stuff to talk about in this part of the solar system, anyway.
Right. Part of what I love about the documentary, it's just the visuals are so staggering. It's literally in the backdrop you have these planets, these vast worlds, and it does make it feel really relevant to how much the solar system is kind of more tangible to us than ever before.
Yeah.
To what sense were you kind of trying to convey that space is no longer just kind of like an abstract for us these days? It is, this thing that we're actually going to be able to finally get to see for ourselves.
When I was a kid, reading about the universe, about astronomy, it was like a fairy tale. These worlds were so unimaginable. You couldn't touch them. You couldn't visit them. We didn't know what was on Mars. Venus was this fuzzy tennis ball in outer space. Now we can go out and reach these planets. We can send probes there. We can visit them. In fact, some of the people that are watching this show, their children will perhaps live on some of these worlds. They'll perhaps live on the moon in a colony. And these things are simply abstract talk of some kind of lunatic. Now we have billionaires. NASA's been reinvigorated. Some people think we're entering a new golden age. Not just a golden age of the 60s and 70s when we went to the moon, but no, another golden age where we can actually have settlements on the moon and Mars, and we can touch pieces of Mars.
You know, when Galileo first looked through the telescope and saw moons around other planets, I mean, it was still right on the edge of fantasy. How could this even be? But now we're actually there. We're driving a satellite through the plumes of a moon that's going around Saturn, it's unbelievable that that can actually be happening, and yet it's real. And that's part of the idea of the MiniVerse show, is to let people see the reality of it. What is the wild difference between those planets and moons, and how does it fit into the context of what we're all thinking every day?
Not to mention the fact that we could soon have a traffic jam. A traffic jam around the moon, around Mars. The Chinese are going to the moon by 2025. 3 booster rockets are perhaps going to be headed for Mars in the next decade. NASA's SLS booster rocket, Elon Musk's Falcon Heavy, and now Jeff Bezos' New Glenn rocket. Think about that. A traffic jam over Mars. Who would have thought? And this means more interest. It means more young people are going to say, I want to go up there. I want to see what's out there in my backyard. It's going to reinvigorate science. Just like Sputnik helped to jolt American education back in 1957, just like the MiniVerse series now is going to spark a lot of interest among young people, I think in the future people will say, my God, my kids could live there.
I mean, speaking of which, you've gone on record saying before that you would take on a one-way trip to Mars.
We had a conversation about it during MiniVerse, so who might want to go? Yeah.
Do you think you might actually get that opportunity, and would you want to join him on that trip as well?
Well, I mean, there's a couple ways to look at it. We're all on a one-way trip, whether you want to be or not. And you're going to live a life and you're going to end up somewhere. So the real question is, what do you want to do during that life? What's important to you? And none of us last forever. And to me, exploration, discovery, trying to figure out the stuff we don't know yet, it's what I've devoted most of my life to. It's what I really love. And one of the grandest adventures that's challenging us right now is not just exploring the world or even the moon, but kind of the lure of Mars. And we're just getting the technology now, as Michio was saying, that makes that possible.
And as Carl Sagan once told me, we should become at least a 2-planet species, because the Earth lives in this cosmic shooting gallery of asteroids and meteors. At some point in the far distant future, the sun is going to eat up the Earth, and it's all going to be over. So at some point, we have to leave the Earth. Not anytime soon, but we're going to have settlements in outer space, just for insurance policy. Because the Earth is the only cradle for humanity, we need a backup. Earth 2.0.
Part of the solar system, most of the solar system, there's not really an Earth analog, The closest thing we're kind of debating right now is Mars, and there's still a lot of issues with that. To what extent do you guys think that we'll have to kind of venture off to find, that actual Earth 2.0? There's a lot of talk these days about discoveries of exoplanets. Do you think it's really necessary for us to kind of venture off past the solar system, or can we just kind of figure out ways to adapt ourselves?
Very few of the 7.5 billion people that are alive on Earth today could live the lives they live without technology, without the scientific invention that we've had. The electricity we take for granted, the plumbing, the connectivity, the temperature control, the clothing that we wear. Michio and I did not knit this clothing ourselves. Someone did it for us. We rely on the technology around us to make the part of the world we live in habitable. Otherwise, we couldn't even live here. Millions, billions of us only live at the grace of technology. So that's no different if you're living in Antarctica, or if you're living in Toronto, or if you're living on the moon. It's just a matter of how good and reliable is your technology. Or the 6 people that are living on the space station right now. They're thriving up there. That's our first little Earth 2.0, is the fact that we left Earth and 6 of us live on a spaceship. And I think that stepping stone of technology enabling us to live places we've never lived, that's what's going to get us there.
And speaking about living in outer space beyond the solar system, we have a census now, a census of the Milky Way galaxy. And we now realize that perhaps 1 in 20 stars have Earth-like planets going around them. The problem is, even though there could be 1 billion Earth-like planets in our own backyard, the galaxy, how do you get there? Mars is achievable. We can do it with yesterday's technology. We don't even need tomorrow's technology. It's a question of throwing money at it. And that's where these billionaires are coming in. They're opening up their checkbooks so that we can go to Mars. So Mars is attainable. And also we can terraform it. It's not going to be easy, but we can induce a greenhouse effect on Mars so that Mars will have melted ice caps, rivers that flow, and perhaps even seas and oceans like it had 3 billion years ago.
Do you think it might actually be feasible to kind of terraform Mars, turn it into something that's kind of this middling ground between a blue Earth and a red Mars, and create a mishmash? So
You're just talking an energy source.
Right.
And if you look at where we were 500 years ago with wood, as the main heat generator, or coal, or peat, and then look at what we take for granted now. You move the thermostat on the wall and your house gets warmer and you don't even think why or how. Changing that energy source to be as compact and portable as possible, that's the technology that's needed, not just on Mars, but of course here on Earth. But the stepping stones, the technology, the expectation that that's going to happen, I think is all real.
And also, if you take a look at the other planets in the solar system, like what we do in MiniVerse, you realize that Mars really does stand out. Mercury is extremely hot, being so close to the sun, and Venus is even hotter. It has a runaway greenhouse effect, so hot that lead would melt on the surface of Venus. So Venus, instead of being the goddess of beauty, turned out to be a hellhole of runaway greenhouse effect. And then we have the gas giants, Jupiter, Saturn, Uranus, Neptune, and perhaps even moons of them like Titan.
Right.
May sustain life or sustain colonies in the future. And so if you take a look at the entire solar system, you realize that there really are prospects for a future home.
Right. I mean, certainly we, just heard last week with NASA's announcement about, ocean worlds and
Enceladus,
right?
right?
The
Moon of
prospect
Saturn.
Of, do you think it might perhaps be feasible that, like, if humans were to venture off to those kinds of worlds, we could build like a kind of aquatic habitat?
I think what's really worth thinking about there is just recently up on the shores of Hudson Bay, we found fossils from 4 billion years ago, when the Earth was only 500 million years old. And if you look at what made those first fossils grow, the very earliest forms of life, it's really similar to the environment that exists on Enceladus. So life created here under those environments may be life created there. Whether that's the place we want to live, I think I'm sort of with Michio that Mars would be a more natural place for people for now. Almost nobody lives on the oceans on Earth because it's technologically hard for us. We like having rock under our feet, essentially. But if we can find life there, if we can show that there's life on Enceladus, and we know it created itself here or developed here under those similar sort of circumstances, maybe it did on Mars, maybe it's currently ongoing on Enceladus. I think that's the real question we're trying to answer. Are we alone when we look at those, how many number, 20 million in our own galaxy? Are we alone?
Billions,
Yeah. Are we alone in that or not? Yeah, the numbers become staggeringly huge when you look beyond our own galaxy, of course. Are we alone or not? Maybe we can answer that question right here in our own solar system.
And it's fascinating to think about alien life forms that could exist under the ice cover in Enceladus or Europa. They would be totally aquatic because they were underneath the ice, and they wouldn't have the internet. They have no electronics because electricity would short circuit inside an ocean, and so the technology would only go so far without the internet, without radio and television. However, it's fascinating to think about this, that there could be life forms in our solar system, and maybe even beyond our solar system, life forms in outer space. We are children with respect to understanding life in the galaxy.
Jordan, we have some Facebook questions.
Yeah, people are asking a number of things. A lot of people are wondering about terraforming. How realistic is that, and how soon, if so?
Well, terraforming is a long-term process, but if you can raise the temperature of Mars by 6 degrees, it becomes you have a takeoff effect. What happens is more ice melts in the polar ice caps, which releases more water vapor, which is a greenhouse gas, which melts the ice caps even more. And you have a runaway greenhouse effect in a positive direction, heating up Mars. The question is, how do you raise the entire planet by 6 degrees? Now, Elon Musk raised the possibility of dropping hydrogen bombs over the ice caps. He has since qualified that comment. But there are ways in which we can begin the process of melting the ice caps, injecting methane gas to jumpstart the runaway greenhouse effect on Mars.
And terraforming is, it's a great big word that in this case means an entire planet. But of course, we terraformed Earth hugely. We have modified the local environments. We have changed the topography. We've changed the constituents of the soil. We've modified how the water gets delivered. So, we have this grandiose term, but if you just look at it in little bite-sized chunks, terraforming is what we've done as a species, starting with agriculture 10,000 years ago, and it's really always just limited by how good is our energy production and our power source, and then our imagination after that. So if you start saying this is impossible, I think you're not looking at history or the limits of our own invention.
Right. And the greenhouse effect is real. Take a look at Venus. We once thought that Venus would be tropical. Science fiction writers talked about vacationing on the oceans and tropics of Venus. Now we realize that its atmosphere is made out of almost totally carbon dioxide. It is a one-way trap for sunlight's heat. And that's why Venus has a temperature of 900 degrees hotter than a baker's oven, enough to melt tin and lead.
Right. As you guys have been saying, kind of the idea, especially in the modern era, of just what we've done to the Earth, it seemed impossible just 100, 200 years ago, and we've done all of this. Changing Mars does not seem like such a staggering feat at this point. Michio, I know that kind of you have a kind of history of making a lot of predictions of what might happen in the next century or so. I'm curious to know if you have any kind of like specific ideas of, what you think Mars might look like after we finally, established a permanent presence there after a century or so.
Well, if you take a look at a timeline, we're talking about the 2030s. The 2030 before we have the first basic settlements on Mars. By 2050, 2060, we're beginning to have not just a few astronauts, but a little colony, a beginning of a colony. By the end of the century, perhaps the first settlements. And then if Elon Musk has his way, he wants a fleet of 1,000 Falcon heavy rockets, each one with 100 passengers each, to create the first cities on Mars, perhaps early in the next century. And after a certain point, these colonies become self-sufficient. They'll have mining operations. They'll be able to create their own infrastructure. They won't need a life support from the planet Earth. They'll be able to create wealth. And then if they harvest asteroids, they'll be able to even make money doing this. Think about that. Platinum inside the asteroids could be valued up to hundreds of billions of dollars per small asteroid. And so that would help to pay for itself, to create an infrastructure on Mars.
I think if you look in Antarctica, the first people to ever even sight it were in the early 1800s. The first person to the South Pole was in the early 1900s. But about 50 years later, we started settling Antarctica. And now thousands of people live on that continent. And almost 100 of us live in the wintertime at the South Pole, the most remote and maybe one of the most ecologically difficult places on Earth to live. And that has all happened over the same sort of time scale that Michio's talking about. And it's all because of discovery, invention, exploration, application of technology, and then using that new place to add to our overall understanding of the world. That's sort of an evolution that has already happened that you just need to flip forward to predict the future of a place like Mars.
And just remember that in 1803, when Thomas Jefferson purchased the Louisiana Purchase, he doubled the size of America, but he thought it would take 1,000 years. 1,000 years to complete the colonization of the Louisiana Purchase. What happened? The gold rush happened. People discovered gold in California. 300,000 settlers converged on San Francisco within a matter of a few years. California became a state the year after that. Things accelerated, and there could be a new gold rush in outer space.
Great.
People were asking about the atmosphere in Mars or other places that we might colonize. How do we deal with the difference in that and how humans breathe?
Initially, you're just going to put, just like we do on the space station or somebody underwater, you're going to put a bubble of atmosphere around them. That's the easy, close solution. And you can process the atmosphere of Mars. And I've read that for every cubic foot of dirt on Mars, there's a liter of water. in there. There's an enormous resource of hydrogen and oxygen if you can just find the energy in order to be able to release it. So I think we'll start with a little bubble just for the first astronauts that get there, but then you'll just slowly increase the size of the bubble until you can put more and more people underneath it. It's not that much different than trying to have a little bubble of air that's warm enough for you or humid enough for you or whatever you need to sustain life. Maybe eventually we can come up with enough changes, you can change the whole atmosphere back to what it must have been billions of years ago. But you got to start somewhere. And I think initially you just make a small habitable zone with a mixture of oxygen and nitrogen like we have on Earth.
And what you don't want to do is take off your spacesuit on Mars or the moon. Atmospheric pressure is only 1% on Mars of that of the Earth. If you were to take off your spacesuit, you would be like Arnold Schwarzenegger in the final scene of the movie Total Recall. First of all, your blood would begin to boil. Water boils when you release the pressure on water. Boiling point starts to lower. Blood will boil and your skin will start to expand just like in the movie. And in a worst case scenario on the moon, you might even explode. So that's the last thing you want to do is give up your spacesuit.
Earlier we had been talking about, the possibility of perhaps finding life on Enceladus or other moons in the Saturn or Jovian systems. A lot of Hollywood movies, especially like Life these days, portraying these like pathological, hostile kind of life forms. I'm wondering, what do you guys think are the odds of actually kind of finding extraterrestrial life somewhere? And if so, what are these kind of organisms supposed to look like? What are they most likely going to be?
We only know life really under one definition. It's fairly similar to us. And we've looked back in the history of the world, and there's, if you look at that great big wheel of all the types of life, we're just one tiny little branch. But we don't think of life, say, as electronic circuitry or as maybe something we haven't even imagined. But if we just look at the conditions that created life here, then, as you say, Enceladus, we think of the world as some beautiful, unique water world. But if you look at which of the moons and planets has water, we're actually, I think, 7th in the solar system. There are other places that have significantly more water, and even liquid water, than Earth. So even if we limit our definition of life to life as we know it on Earth, the odds of it existing somewhere else in our solar system, at least from our understanding, are continuously increasing. And we've never been closer than now to discovering life somewhere beyond the Earth. And that's only with our own limited definition of life.
And if you take a look at intelligent life, we realize that we became intelligent basically through 3 mechanisms. First is eyesight. We think that aliens will have some kind of eyesight, perhaps stereo vision, the vision of a predator, because hunters are smarter than prey. We say sly as a fox, and we say dumb bunny. Second, a hand, a tentacle, an opposable thumb, some way to grasp or manipulate the environment. A claw, a tentacle, a thumb. Third, language, by which you can propagate information from one generation to the next. Now, take out a sheet of paper and make a list of all the animals that you know and see which ones have all 3. And you realize the answer is almost none. Think about that. Dogs, cats, yeah, they're intelligent to a degree, but they don't have the way to manipulate the environment. The octopus has the way to manipulate the environment, but has very, very poor eyesight, no language that we know of. And then you begin to appreciate how we became intelligent. So in outer space, yeah, I think they're out there. I think there are intelligent beings with some kind of hand-eye coordination, some kind of way of propagating information from generation to generation. But if they're really advanced, maybe they may not want to visit us because we're not interesting to them. We're kind of boring. Right. Next time you go into the forest, do you talk to the squirrels? Do you talk to the deer? Do you have a conversation with
the trees?
I mean, you may get bored after a while. There's nothing that you can say to a deer that would interest you. In the same reason, I think that aliens out there are not going to land on the White House lawn. We're just not interesting to them. Sorry to say.
Wow, I can imagine this road trip must have been a very, very good conversation. One thing I wanted to ask, are there any kind of specific points in space science and technology that you guys perhaps disagree with on, with anything that perhaps came up during the filming of the documentary, or just kind of naturally that you guys know that you guys have different perspectives.
Well, we have a different perspective on the question of whether or not we're going to go into outer space.
Right.
Count me out.
Really?
I'm not one of those daring heroics that we see here, just raring to go to the Mars. I realize that, well, let's be blunt about this. 1% of the time, the rocket blows up. We forget that a lot of these pilots are former Air Force pilots. They know that when they go into a ship, a fraction of them may not come out again. I'd rather not go into a spaceship realizing that 1% of the time I'm not going to come back.
But you're already living in space. You just have a little bit of a naturally occurring bubble of air above your head.
Mm-hmm.
So, and you're going to die. So if you take those two things as a given, then why not bring some of that air with you and go someplace that you've never been before? You get in an airliner, which it would kill you very quickly if you somehow lost that bubble of air around your airliner up at 40,000 feet in that aluminum tube, and you're willing to do that, and they crash all the time also. So I just kind of see it as you can't spend your whole life just trying to prolong your life. You need to really establish what it is you want to accomplish. And you do that in space. You just maybe don't want to go to Mars.
Well, I'd rather try to educate the public so that we have true heroes who willingly want to go up there and take that 1% risk.
Right. Well, I think we're running out of time for a bit. I guess I'd be remiss if I didn't ask you, Commander Hatfield. You know, you had this David Bowie tribute that went viral a few years ago while you were in the space station. I would be curious to know kind of your thoughts on, you know, his passing last year. What was that like, and kind of maybe what was his influence? What was his musical influence on you in terms of your kind of thoughts of space and adventure?
Well, he wrote that song when he was still a teenager. You know, before there'd only been 25 space flights total when he wrote that song. Nobody had been to the moon yet. And he was guessing, but he was fascinated by space exploration. It was the undercurrent of, you know, life on Mars and Starman and Space Oddity and all that. And he dreamed about it. He wanted to be able to have that as part of his life. And I got to know him very slightly as a result of recording Space Oddity on a spaceship. And to me, that was the best part of it, was that he loved that version of it. That vision that he'd had when he was 19 or 20 becoming real, and his song being sung in a spaceship. And earlier this year, I played with his band here in New York, honoring him and what would have been his 70th birthday, but nobody in the audience wanted him to be gone. Nobody in the band, you know, celebrating Bowie. They played here and in LA and in Tokyo and London, celebrating the artistic and sort of brave vision that he carried through his whole life. I wish he'd lived longer. To me, he was such a delightful, creative force artistically, but that's often where our greatest inspiration comes. Our artists and our writers imagine things that then allow us to maybe picture ourselves doing those things, and then the inventors move in afterwards. And Bowie was one of those artists.
Is there, Michio, is there any kind of artists that come to mind for you that kind of perhaps inspire or inform some of the ways that you approach science?
Well, I think physics is a form of art in the sense that our equations are like music. And I, as a physicist, am interested in the question of building a starship. We want to go not just to Pluto. We want to go into deep space. We want to visit the stars. There's so many stars out there. What a waste, as they say. They have all these stars without the ability to visit them. But to do that, you have to have warp drive.
Right.
And that's where some of my research comes in, because Einstein's equations actually allow for a form of warp drive. It's controversial how stable it is. It's controversial whether or not we can energize these warp engines. But yeah, there it is staring you in the face. Warp drive is a solution of Einstein's equations. But the equations are not complete. There's a gap missing. And that is the question of the stability of these warp engines. And that's where my research comes in. I work on something called string theory, which actually goes beyond Einstein to complete that missing link in Einstein's theory, so we can calculate whether or not starships are really stable or not. For that matter, time travel, interstellar travel, gateways to higher dimensions. All these things is basically what I do for a living. That's my day job.
Right. Do you think that perhaps we might, in the next century or so, find a solution to warp drive, find a solution to time travel, to these kinds of really wild, abstract ideas?
Oh yeah, personally I think that in the next few decades we'll probably have an answer, yes or no, whether or not string theory makes them possible. However, whether or not we have the energy source to rip the fabric of space and time so that we can leap into the 11th dimension, that remains to be seen.
Same limiting factor to whether we can establish a settlement somewhere else.
Right.
Yeah, energy source is always the fundamental question.
Details.
I've never been in a spaceship or an airplane that goes fast enough. And even if we get on that one, we'll still be going, come on, Alpha Centauri, it's still months away. Never go fast enough.
Great. On that note, I want to thank you both for coming in and chatting with me. Really appreciate it.
Thanks.
I'm sure our viewers have appreciated it as well. Yeah, thanks so much.
Pleasure. Nice to talk with you.
Thanks.
Okay,
Good to see you too.
right.